Okay, so this time here, let's really try to solve some more a quadratic equation that, in a sense, you can see that it somehow look meaner. I mean, the point is, I mean, you're gonna see all those crazy looking coefficients here, and you got like big numbers there, right? And so in my terms, it looks somehow meaner. But then the point is, after you have solved these equations using the quadratic formula, right? Gosh, you're gonna have to just admire how powerful the quadratic formula is going to be for you, okay? And how useful it can be for you. So, and the point I'm trying to show here is that, you know, with the quadratic formula, it's breaking you free from any limitation, okay? So, starting with this quadratic equation that we want to solve for, right? Starting with that quadratic, I see that my A, once again, always, you need to spot out what the A value is, what the B value is, and what the C value is. So my A value, which is the leading coefficient, is a 3. This time it's right there in front of it, right? The B coefficient is a +4. Okay, and once again, practice for yourself the habit that count the signs together with it. And then the C is a -5. Okay, so my formula, the quadratic formula says you can always do minus B, which in this case here is a -4, plus and minus square root of b squared, which is in this case 4 squared, minus 4ac, which is in this case 3 times -5. Okay? And so I'm at this point here, I'm technically just, you know, substituting in the A and B and the C value into my formula, right? And divided by 2a, which is in this case 2 times 1. Alright, so now I can just go ahead and pursue further to compute what's underneath the square root. So I have -4 plus and minus, and then the square root, and what I have is a 16 because it's 4 squared, and then I got the minus, and then 4 times 3 times -5, and then together with that minus right here, so it's going to be a plus, right? The sign changed to a plus, and then 4 times 5 is 20, times 3 is a 60. So now this time I have a 60, right? Plus 60 and divided by 2. Okay? So in my next step, well, of course we keep continuing, you know, we keep computing what's underneath the square root. So -4 plus and minus. Now underneath the square root, you're going to have 76 this time. Okay? And divided by 2. And so now 76. Is it a perfect square? No. So we're not going to brutally have to compute. We're not going to brutally compute square root of 76 using a calculator. But then remember, the nicer way is we're going to reduce that square root, right? And you remember how to reduce that square root. And the question here is that what is the highest perfect square, right? The largest perfect square that goes into 76 here as a factor. And so what I can see is I can, hold on, give me 1 second to. So square root of 76 has, what is it? It has 4 in it. Okay, so yes, it's 4 times 90. Okay, and divided by 2. Well, once again, 76 here contains 4 as the highest, contains the highest perfect square is a 4 here as a factor, right? And so I can take that 4 out of the square root and turn that into a 2 square root 19, okay, and all over 2, okay? And so at this point right here, once again, the plus and the minus here means you can do 4 plus, what I'm telling you here is one solution is x equals -4 plus 2 square root 19 over 2, and the other solution for x is -4 minus 2 square root 19. It's all because we have the plus and the minus. It's like a dual nature right there. Okay, and divided by 2. And so now going a little further, I can break down my fraction here by doing split it out, and I can break apart that I have minus 4 over 2 plus 2 square root 19 over 2. And the other solution is x equals minus 4 over 2 minus 2 square root 19. I don't know why I wrote a 2 there. But divided by 2. And so that will give me x equals minus 2. The 2 here got cancelled, right? Plus square root of 19. And that's one of my solutions. And wait, and hey, I mean, square root of 19 itself is a prime number. It's not a perfect square, so don't brutally try to get an answer for that, okay? You can just safely and nicely leave it as square root of 19. We are good with that. I'm good with that. I'm happy with that, okay? And then the other one, x is equals to minus 2 minus, now once again, remember the 2 here got cancelled, so minus square root of 19. And that is how you have found the solution. So, see, the starting problem, the equation, boy, it looks really mean, right? You got all, coefficients all over, right? But then, so what? Your quadratic formula handles it all, okay? So let's look at another example here of solving the quadratic equation, and then we're gonna be finished up with the whole chapter 8. So my example number 3, actually it's example number 4 this time. Okay, and once again I'm solving another quadratic equation. Okay, and my equation this time is going to look like, I got 3x squared minus 8x plus 7 equals 0. Once again, we are using the quadratic equation, again, the quadratic formula to solve this equation. Okay, so my A is a 3. My B this time is a minus 8. Okay, so once again, count signs with it, minus 8. And my C is a plus 7. Okay, and so to solve for this, once again, I'm using my quadratic equations, quadratic formula, excuse me. So minus B, which is minus 8. Just plugging it in the way it's supposed to follow with the formula. So I got minus B. So in here it appears to be minus negative 8. Okay, plus and minus, and then the square root, and I got B squared, which is in this case minus 8 all squared. I put the minus 8 in the parentheses. Okay, minus 8 all squared. Okay, and then minus 4 times A, which is 3, times C, which is a 7. Okay, and all over 2 times 3. Right. So now once again we can start computing what's underneath the square root and clean up the outside here a little bit. Now minus negative 8 is a positive 8, isn't it? Okay. Plus and minus, and then the square root. Now minus 8 all squared is a 64. And minus, now 4 times 3 is 12, right? Or you can think of like 3 times 7 is 21, and times 4 is an 84, right? And all over 6. And then so x equals 8 plus and minus square root, and this time we have a negative number because 64 minus 84 is a minus 20, right? So we got square root of minus 20 and divided by 6. And so, and remember, it's a negative number underneath the square root, so we do have to encounter with some imaginary number, right? So on my top right here, that will become 8 plus, now, square root of 20 itself. Now, momentarily ignoring ignoring the minus sign, and square root of 20 after reduction is going to give you 2 square root 5, right? And then with the I here. Everybody with me now? Okay? And then divided by 6. Okay, so now what this notation means is that you can, that notation, the plus and minus sign, what that means is you can do x equals 8 plus 2 square root 5i divided by 6, and the other solution for x is going to be 8 minus 2 square root 5i over 6. And then all that turns out to be one solution of yours is x equals 2. You can start breaking the fraction apart, right? You got 8 over 6 plus 2 square root 5 over 6i. And the other solution here is x equals 8 over 6 minus 2 square root 5 over 6i. And so now in each of the solution here, you can do some reductions, right? You can do simplifying fraction a little bit. So 8 over 6 is reduced into 4/3, right? Plus, now you can also reduce that 2 here in this next fraction. So you got square root 5 over 3i. Okay? And that's my first solution to the equation. My second solution to the equation here, after reduction of those fractions, you have x equals 4/3, right? Minus square root 5 over 3i. And that is your second solution of the equation. Okay? And that is how you solve a quadratic equation using a quadratic formula. Alright.